Hello and welcome back to the shop. So today we're going to start leveling the 13-inch lathe. So I needed to get some feet, and I was deciding whether or not to buy them or to make my own. Now, to make my own would have been way more expensive to just buy them, so I just went to McMaster Cart and I bought them. Now the ones that I got are model number, or the part number is BSW-2AZ, and these are going to be swivel base with a 4-inch stud. Now I did swivel base because the floor down here isn't the most level in the world, and that'll give me a nice purchase on the floor if it hits a bump. I could have probably gotten away with 3-inch threaded 3-inch studs, but I went with 4-inch just in case. The only thing is it looks like it's going to block my front door, so the front one I'll probably just have to, once I get this all set and locked down, just take a hacksaw and nick a little bit off of it to let that front cast iron door shut. Otherwise we should be pretty much good to go. So now to level this lathe, especially since this is an older lathe, I can't just go by the level of it, the machine, because this has some wear in it and some other factors too that I may be able to mitigate by playing with the level of the lathe. Now, using a precision level and getting this sucker as level as you can is a great starting point, and from there we can tweak it. So as far as precision levels go, I have 3 flavors here, and we'll go ahead and take a peek on the bench and what we're going to do with these. Okay, so now the reason why we have to level a lathe is to get all the twist, or as much of the twist, out of the bed as possible. So we want both sides of our ways, both tracks that our carriage is going to ride on, end to end, 100% parallel and not twisted against each other. If they're twisted, that carriage is going to rock back and forth and ride that twist like a wave, and that's going to show up in a taper in your part. So now, it doesn't necessarily, we really don't care about level per se, we just care about perpendicularity of the two bed rails to each other. But level is the easiest datum to use to figure out the relationship between one side of the bed and the other, so that's why we use it. Now, you need to get down to where you need to be for a lathe, you need a precision level. So we're going to use the precision level first to get that relationship as best as we can, and then we're going to start taking test cuts and check our relationship of our cut between one side and the other, and we can figure out how we're cutting a taper and adjust the lathe to compensate. So now, as far as precision levels go, there are many out there and a lot of different sensitivities. So this is a Starrett 98, this is an 8-inch here, and this is sensitivity of 5 thousandths per foot. This will get you in the neighborhood. It's not the greatest thing in the world, but they're everywhere, and actually they can get kind of pricey just because they say Starrett. On the other end of the spectrum, this here is a very cheap import. See, it says CDCO there. I think this is like $75 when I bought it, but you can see this is rated for 0.2 of a thousandth per 10 inches. Whether it actually is that, I couldn't tell you, but it is pretty damn sensitive and it works great, and for $80 you can't really go wrong with this. For this size of lathe, something like this should do good. The longer the lathe, the longer the level, the better it is. Now we also have this pretty cool one here, which we're also going to use, and this is an actual Southbend precision level. This is a 12-inch model. Now, as far as sensitivity on this one goes, I can't find any info about that, but if you look in machinery, not machinery handbook, in the how to run a lathe here, it says in there to use a level that when a 3/1000 shim is put under one side, a significant movement of the bubble can be observed. So what the actual sensitivity of this is, I couldn't tell you, but obviously it's somewhere in what they're stating for an ideal level. So now I want to check the actual 0 of these levels and make sure they're calibrated. I haven't checked any of these, so we're going to check that and I'm going to show you how to check a level. And the cool thing about levels is that they're self-proving and you really don't need anything super fancy. Okay, so here's a granite surface plate, and this is actually a cheapo one. This really isn't that expensive. I think I paid 25, 30 bucks for this from Woodcraft, of all places. They usually, it's a woodworker's warehouse, usually use this for sharpening and honing, and it's flat enough for what we're doing. So, as I said, levels are self-proving. So all you need is a nice flat surface, which is this, and a Sharpie. So what we're going to do is take a lint-free cloth, and I had already wiped down this surface here. I got a little bit of denatured alcohol on here just to clean the bottom of these levels because they've been sitting for a long time. Make sure they're nice and clean. And we're going to open the vial. And hopefully the light doesn't blow this out, which it probably is. But what we're going to do is I'm going to shut this off and see if that helps a little bit. Hopefully you guys can see that. What I'm going to do is I'm just going to turn this until that bubble is in between those two large lines. Okay, so that's right about there is pretty good. We're going to take our Sharpie and we're going to mark the corner of that level. Now we're going to take it, spin it 180 degrees, and we are going to put it as best we can in that same spot. And our bubble, as you can see, is in the exact same position. So this level is calibrated correctly. It reads correctly. I'm going to do the same thing with all the other levels and make sure they read the same. Okay, so here's our setup. Now what we have is 1, 2, 3 blocks that are actually the perfect side to sit into the lower edge of the ways here where the carriage doesn't ride. So technically these should be virgin areas. They should never have been touched by anything. Obviously there's little pock marks here and there from people and dropping things and everything else, but I stoned them the high spots down, and the 1, 2, 3 block fits perfectly in there. So I have one set up on the front and a couple set up and the other level set up on the back. I have the carriage directly in the middle of the machine. So what I'm going to do is keep reading these, and I'm going to work the set bolts on the feet and raise and lower them until I get these two level, or as level as I can. Now we're not so much worried about level this way, we are worried about level this way, here. Okay, so once we get it pitched the way we want, we can kind of adjust this a little bit to get that into position. It should be relatively straight though, but we're more worried about twisting the bed rather than the bed being toe forward or head forward. So I'm gonna do all that off camera because there's gonna be a lot of back and forth and crawling around and jacking up bolts and stuff, and that's really not gonna be the meat of this video. So we're gonna get this sucker in line by level first, and then we can actually mount the chuck on this and put the tool post in, and we can take some test cuts and we can fine tune that level. Okay, so I mentioned the two collar test, where what would happen with that is we would put our chuck on here and we would grab a piece of stock in the chuck, and as you can see we have two different collars here. Alright, they're about 4 inches apart. You take a cut off on one side, and then not changing the setting of your compound or your cross slide, take a cut off the other one, and then you can mic over them and see what the difference is. That difference is your taper. So I did a little bit of experimenting, and I was planning on aligning the lathe that way, but the 3-jaw chuck that came with this lathe is all kinds of whacked out. And I do have a 4-jaw that I got to put on this, but I need to make a back plate for that, and I don't have the stock to do it. So what I ended up doing is going online, and I actually ordered a test bar. So now this test bar, it's offshore. I think it's made in India. Seems pretty good. It's got a little bit of offshore stank to it. And, you know, it's a Umex. This is what it came in. I do have to say, this box, the cardboard box that it was in, this box reeks. I don't know what the hell this is made out of or what kind of chemicals were in this, but holy crap, does this box stink. So that's getting thrown away. But the bar itself doesn't look too bad. Now I got a number 3 Morse taper so that I could also use this in the tailstock to align that, and also use this in the Southbend. Now this is a number 4 Morse taper, which means I needed an adapter. So I got a name brand adapter here, it hardened shanks, so hopefully we won't end up with a ton of run out on this once we get it in place. So make sure everything's nice and clean, and this taper already clean the crap out of it, give it a little bit of a tap to seat it. Take the bar, give it a little bit of a tap to seat it. So now we can use this as our gauge surface and basically just run our compound over it, and that'll tell us what we got. But what I want to see now actually is how bad the run out is on this, and we can probably adjust a little bit by giving it a knock or two. And so we are, from the actual thread face here, we are 11 inches out, so that's pretty far. And yeah, we're running out pretty damn good there. So even if everything was tweaked, this shouldn't have any run out to it. But I only paid $30 for the bar, so you know what, I'll be honest with you, I'm not expecting much, but that's a little too much. So let me see if I can just give it a little tappy tap. Okay, that run out was actually my fault. I had an impacted chip underneath the adapter there that I didn't see. Probably stuck on the back of the tang when I put it in the first time. But anyway, I went through everything, just double checked with some bluing, and everything looks okay. And I actually put this bar directly into my 9-inch, directly into the spindle, because it is a Morse Taper 3. And I'm getting less than a thou run out at 11 inches. And in here I'm getting about the same, about 3/4 of a thou run out at the end, which is, for me, in all honesty, is perfectly fine. So now my setup is, this indicator here is perfectly perpendicular to this bar using a machinist square, and it is perfectly on center height. And I don't know if you guys can see it there, but the tip I have on there is really pointy. The reason why I want to have the smallest contact area is because this carriage, no matter, we already know this wear, this carriage is going to drop. All right, so if I have something like, say this is the bar, for example, and I have an indicator button that can span that whole edge, as it drops, it's still going to ride on that flat edge. All right. Now, if I have a nice pointy indicator, say like this screw, as it travels down, it's going to be able to ride and go underneath the center line and give me an idea of what my run out will be. So we're going to start here and work our way down and see what we get. And then we're going to try to adjust our bed a little bit, because we're probably not perfectly level. We're going to adjust it a little bit, and we're going to see if we can kind of work that out, or make that as minimal as possible over this distance here. Now, no matter what, there's going to be some sort of taper that this lathe will cut. Any lathe, any Hughes lathe is going to have some wear, and the wear is going to be, most of it's going to be over by the headstock here, and it's going to peter out as you get to the tailstock. So what we're also going to do is we're going to pop an indicator on the top here, and we're going to see what the actual carriage drop is. Now you got to remember that the actual amount that the carriage drops doesn't translate to the amount of taper that you may get in a part, because you have kind of, it's think of your trig. You have a triangle, you're going down at an angle like this. You're not all of a sudden dropping 5/1000ths and pulling that out. So you won't see, they won't correlate to each other. As this gradually drops, you may have a little bit of a taper, but you're not going to have the same. So in other words, you have 5/1000ths of drop over this top, you're not going to have 5/1000ths worth of taper. Okay, it's going to be different. So, I mean, wear plays a big part in everything, but again, I'm not making stuff for NASA down here, and I want the capabilities of a larger lathe. Wear isn't a huge thing because I'm going to be working in short distances. And a lot of times is you can kind of negate a lot of that taper by learning your lathe. I mean, just look at some of Keith's videos where he shows you, you know, the carriage, and you can pull it, move it in and out and everything else, and you can see the quality of work that he does. So I'm going to take you off the bench there. We're going to sight down to this dial indicator, and I'm going to actually set another one up on the top, and we'll see how much this carriage over this 11 inches drops and tapers out. Okay, so hopefully you can see that. I have the indicators lined up, and like I said, we have the pointy indicator on there, so we'll be able to track around the actual diameter of this bar and be able to track down just like a tool would below the center line. So we're going to start there. I'm going to crank ourselves in so you can see we're dropping, and over that distance there, right to there, we've dropped 6/1000ths on the top there. So this whole carriage has gone down by 6/1000ths, and we've gone out by what? 2? 2, just a smidge over 2. So our diameter here is smaller than our diameter out here. Diameter out here is larger than our diameter here. So I want to see what will happen is if I give that outside right leg a little bit of lift, if it'll kind of twist the bed in and twist this cutting edge in slightly. So I'm going to give it a quick adjust, and we'll see if I can kind of negate some of that. Okay, so now I've turned that screw about a quarter of a turn, and without touching anything, you can see, or hopefully you can see here, if it'll focus, that dial indicator has actually dropped by almost a thou. So now we're going to try this again. I'm going to re-zero. And now my difference is 3/1000ths in the wrong direction. So let me go back to where I was, and we'll try this again. So I raised that front right. Means I got to drop that one and raise that rear one. So let's give that a shot and see what happens. Okay, so I'm going to raise that leg, and we're going to see that indicator move. It's about a quarter of a turn, and that indicator's gone up by 1,000. So let me zoom you back out, and we'll see if that made any bit of a difference. Let's re-zero it there. So now we're within 1 thou over 11 inches. I'll be honest with you, that ain't bad. I'm going to leave it at that for right now, because I really want to do test cuts with it to actually test that. So I'm going to leave that and lock everything down at that. So I don't want to go crazy and get this 100% zeroed and then realize that I got a ton of twist in the bed, and when I get down to the other end, it's all out of whack. So 1 thou over 11 inches right now for this lathe, I'll be honest with you, ain't too bad. And you can see it flicks up right there. Yeah, I think I'm going to leave it there because you can see how it drops. It gives a sharp drop right there. which is right where it starts to tilt. So I think I'm gonna, like I said, I'm gonna leave it like that, and then we'll confirm all this with test cuts. But that's pretty good for right now, I think. All right, I'm gonna wait for the tailstock until later because I got a few other things I gotta do with it. In the meantime, let's make a cut with this, huh? So let's turn on our VFD. Like I said, this chuck is just pretty much garbage. There's a touch. Let's say we'll take 50 thousandths. That's not too bad. That's a pretty good finish. No real striations in there, so there's not a whole lot of vibration in the machine, which is what I was worried about raising it up on those swivel casters. But there doesn't seem to be any vibration in there. What I'm going to do is I'm going to take one little quick pass at the same setting to clean up this, take whatever push off I can get, and just for, you know, just for S and G's, we're going to mic these two collars and see how close we are. You can see we're just taking a little whisker off of there. That was tool push off. Plus, as I said, these jaws on this 3-jaw are all kinds of out of whack. Even the back plate's garbage. And we're not taking anything there, so we had no tool push off on the inside. All right, so I got the mic, and we're just going to measure both of these and see what the difference is. So we got 1 inch, 159, 1 inch 159, and right here we got that's 1 inch 158 or so, or just shy of 158. So like I said, there is a difference here, but I'll be honest with you, I do not trust this chuck at all. These, I can clank it around a little bit. This back plate's kind of screwed up, which is why the test bar gave us a pretty damn good reading, and that'll give us a nice starting point once I get the good chuck on this, and then we can kind of tweak from there and see what I'm actually going to get. So, okay, so I just want to show you how kind of ugly that chuck looks. Now you can see the back plate there doing the wobblies. The chuck itself looks okay, and then those front jaws, one of them is off. At least one of them's off. So I don't, and these jaws here are pretty loose. I mean, it's just worn, it's old, and I don't trust it. So this, I'm almost positive this is a huge source of a lot of the movement of this piece here. So I have a nice or decent 4-jaw chuck that's gonna go on this. I just need to machine a back plate for that. Alright, so I hope you guys enjoyed this video. So this is a preliminary level on this. We can fine tune it once I get a solid chuck on this that I can trust, and we can fine tune the level and try to take out as much taper as possible and then align the tailstock. Now, this lathe obviously has wear. I think the total drop from one end to the other through it is about 12 thousandths or so in a wear in the bed, which I'll be honest with you isn't ideal, but it is what it is, and for the added capacity of this lathe, it's perfectly suited to my needs. The only time that'll run you into trouble is when you're trying to split hairs, and also like long shafts and things like that, which I don't do. So most of my work is up near the chuck, which we're not going to see that much taper on that. I think my 9 by comparison from one end to the other has about a 4,000 wear in that entire bed. So there's a little bit of a difference in that. But perfectly happy with this, and you know, if something bigger and better comes along, so be it. But for right now, this thing is meeting my needs perfectly. So I'm going to get some stock for that back plate, and hopefully I can get the next video out of making that, and we can get that sucker mounted to this and get this 100% dialed in, and then we're complete. I know it's kind of taking forever, but you know, it's a process and we're getting there. So hope you guys enjoyed this video, and we will see you on the next one.